This is just to show some of the instruments that I've accumulated to carry out demonstrations, experiments, and to use in the field on my various trips. The oscilloscope, which is shown here, it's a USB oscilloscope, and it works through a USB connection onto the computer. And this is a data logger, which is coming off of this particular beta over here, which can be used in the field to send off the data to the central computer, which will log it and present the graphs. This is a unit which is in fact a data logger in itself. It will record and store 40,000 readings of any sort that you want. It will make voltage measurements or microamp measurements, whatever you want, and it will store them. And then it can be downloaded into the computer through a RS232C connection, which dumps the data into the computer, and then you can present it in any way you like and analyse it. This is the old style analog meter, which is, I use this to show how the difference is between an analog and a digital meter, whereas the analog meter draws current to move the needle across, which will present the reading, but a digital meter doesn't draw current for that purpose. This is a clamp meter. It's a voltmeter and a current meter, and the process of using this is you clamp this round a conductor, and the theory is that the magnetic field formed by the clamp will pick up the charges, the effect of the charges going through the magnetic field, and that will activate the meter and give you the reading, the current reading in here. The problem with that is that it is measuring the effects in a magnetic field, and there are all sorts of external effects that can corrupt the readings in that magnetic field from extraneous sort of stray charges. And this meter I use, there are 4 meters here that I use to synchronise and take what is known as pipe to saw readings, but they're not pipe to saw readings the way that I do them. I set it up so that each of these meters is connected to a looping capillary right to the anodic interface between the electrolyte and the metal of a single pipeline. So I have these 1, 2, 3, 4 connected up so that each one of them will show the variety of readings that we get from a variety of adjustments to the impulse current system that I actually put onto the pipeline, or the short length of pipe which represents the pipeline. Ideally this should be done in the field, but it can only be done in the field when you're using an Alexander cell, because that's the only way that you can put a looping capillary to the actual interface of the anodic surface. Whereas all these attempts that are made to put a coupon and connect that to the pipeline and say that you're taking a proper pipe to saw reading at the interface, you're not. In fact, you're taking the pipe to saw or pipe to coupon reading at both the anode and the cathode, because there are, on every coupon system and every coating fault on a pipeline, there are both anodes and cathodes. The requirements of DIN 50918 is that the measurement is taken at the working electrode, which in fact we know as the anode. The return electrode must be separated so that you can get the readings and the measurements, the proper potentials these are, in relation to a proper reference potential in closed circuit condition. And this is where all the recommendations except cathodic protection network recommendations miss the very point of how to measure cathodic protection and its effect on corrosion cells. The other meters I use for microammeters and for various voltage readings in the various experiments that I set up. And the reason why I've got so many is because I've got 6 demonstration pieces, each with different features of cathodic protection, and each one has to have either 1, 2, 3 or 4 meters to show synchronously what the effects are when I switch the transformer rectifiers on. I have 3 transformer rectifiers, and in fact I can make up several systems of pipelines and measure the effects on all of the systems as each one of them is switching. So that's the reason for all this. This is the switching device that I've made, and I can make another one. I've got another one over there that I can make to make it synchronous or asynchronous with this switching device. So this is my instrumentation. I've got a few other bits and pieces as well, but they won't fit on the table.